All right, I want to show you guys a few things that we can do um, without having a graph. We actually did questions like this yesterday, talking about how predator prey populations can be cyclical and we can model them with periodic functions. We're going to do some of the same questions we did yesterday and some new ones. But we're going to do all of the stuff we're going to do, we're going to get strictly from our equation. So what you guys can do to start, and I should say too that for on this document, for each kind of type of question I expect you guys to be able to do, I've actually got a key idea on how to do it. So that's just the kind of guy I am. But you guys can start with A, maybe while I do my attendance. So from the equation, you guys have a lot of experience finding the period. So I'll let you guys get that done. I'll do my attendance real quick. And then I think we'll do B together. All right, who among you has found the period for this function? Andrew? It is 4. Andrew, how'd you get 4?
I did 360 divided by 9.
Perfect. All right, so you guys should be able to get a period from equation. One thing we haven't done a lot of is actually worked with our equations to make a prediction. So in part B, I've asked us to find the population of this, whatever this prey is, in 1990. No problem.
I have Madeline Montgomery, services.
Okay. Yes.
Thank you.
You're welcome. So our model gives us how many prey there are after 1980. So t equals 0 is 1980. 1990, we're going to plug in t equals 10. I don't think we've done a question like this before. We're going to take our equation, replace t with 10, and find out how many, I'm just going to say zebra, because that's in the picture. How many zebra there are. So we are evaluating n at 10. So whether you want to put this all in at once on your calculator, and if you're using a display calculator and you're good with brackets, you can put that in as you see it. Or maybe if you're like me, you can do this since I have the space. You can kind of do things one step at a time using order of operations. I'm going to do this with lots of steps. 10 minus 5 is 5. You got to do the inside of the sign stuff first. And then 90 times 5 is 450. And then at this step, I'm going to just use my calculator to evaluate the rest of this. Yeah, it's basically just plug and play. Kind of like, in my opinion, free marks. Put in a value, use your calculator. But here we use 10 because 1990 is 10 years after 1980. I should be able to do this in my head. It's 250, I think. Nope. Yep. Nope. 750. I don't know. I should just do it. 250 times the sine of 450 plus 500. Yeah, 750. Did you guys get that too? All right. And we're going to lock it in. It is zebra. Is it zebras? Is that the plural? Or is the plural of zebra just also zebra? Who can say? I don't know. All right. The second thing, or the third thing you guys should be able to do strictly from the equation is find out how high it gets. Now, I know most of you guys can do the mental math here and have probably already answered this question. But I'm going to do this one in a very specific way. to help us with part D. So you guys know, or should know, that the highest the sine function ever gets is 1, right? Goes up, comes down. You guys should know at this point, it's bound between 1 and -1. It never gets to be more than 1. So if you want to know how high this function gets, what's the maximum population, we're going to add the amplitude to the axis value. And what that looks like would be this. I'm just going to write n. The amplitude is 250, but I'm going to multiply by 1 because that's the highest all of that sine stuff can ever get is equal to 1. And we're just adding 250. So essentially we're adding 250 and 500. 750 again. But I'm going to throw in that 1 just to emphasize it's because that's as high as sine ever goes. Now this is some new tech for you guys. This is something we haven't done yet. What year did this occur? I know there's multiple years, but we're going to use our equation to find when this occurs. I have this over here in your brackets, but we have to have a good understanding of the sine function. When does our sine function get to its highest point? It's when the angle is 90, because it's the sine of 90 is equal to 1. So if you want to use your equation to find when that happens, you've got to say, okay, when is the inside of my sine function, when is this stuff equal to 90? Because that will make sine of 90 equal to 1, and I'll have my maximum. So we're going to set whatever's inside the sine brackets equal to 90, and we're going to solve that equation. So in our question, we have, what is it, 90 times t minus 5. And we have to find out when is this equal to 90. Why? Just talked about it, and it's in the margins there. It's because that's when the sine function's at its highest. This is an equation that most of you guys solved in your, you guys all solved this in grade 9 courses, grade 10 courses. I'm going to just solve this in a specific way. I'm going to expand the left-hand side and make it a 2-step equation. And then it's a 2-step equation. We're going to add 450 to each side. You get 90t equals 540. And then to get t by itself, we just divide both sides by 90. This is just going to give a surefire way to do this for people every time. So what year did this occur? T equals 6. The year corresponding to t equals 6? 1986, right? 6 years after 1980. Now you guys know the period is 4. So when did this occur? Well, also in 1982 and 1990. But this is what our equation spit out. A year where that maximum occurs. Can you guys do the same thing with the minimum? So the lowest the sine function gets is -1. So for E, you guys do what you did in C, just use -1 instead. And then when you're finding when that occurred, do the same thing we did for D, except the minimum for the sine function occurs when the angle is 270. We'll set the inside to 270. I can just do E along with you guys because it's super quick. So what was the minimum population? Well, the lowest sine gets is -1. And what you end up getting is the axis, 500, minus the amplitude, 250. You just get 250. The same as before, but I'm emphasizing here that the lowest the sine function gets is -1. 250 zebras, we'll say this time. When did this occur? Same idea. Can you guys use the equation? We're going to set the inside of sine equal to 270. Why 270? That's when sine is at its lowest. So while you guys do that, and remember, this is going to give us one possible year. I'm going to get everybody what they need for today, for either the new lesson or the series. I'll do the M's first.
Give you the second one. I got to do. It's a nice job. You do this one.
Apologies for the extra page.
And we get.
Yeah, I will pass.
Sorry. Wait, I was going, but I remember.
All right, let's wrap this up and get you guys going. All right. Did you guys get 8? So 1988 as well? Nod and smile. Of course, the period is 4. So this would happen in 84 and 1992, et cetera, et cetera.